Acha, acha, okay. So still it's better. Good. Okay, okay, nice. Okay. So that really motivating us. Okay, good. But we encourage you to attend all the other classes also.
Good afternoon, sir.
Good afternoon, everyone. So what was yesterday's topic? Okay, let me mute everyone so that we don't have much time. Yeah, please do make use of chat box. Okay, as you know, we have less time and topics has to be covered many. Okay, yeah. So what was yesterday's topic? Sampling. Good. Yeah. So what do you mean by sampling? So what do you mean by sampling? Because we're talking about sampling and sampling techniques. Okay. So you should be very clear with what you mean by population. Yes. Okay. Representing population. Okay. Good. Okay. So you should be able to tell what is population and why or what are the factors or reasons for selecting a limited number of people. Okay. So that selected limited number of people are called as sampling. Okay. So population we have, sample we have. The techniques which are used to draw the limited number of people sample is called as sampling techniques. Techniques used to draw sample is called sampling techniques. Under that we had to what all that we discussed yesterday only. Maybe someone if they have joined today, okay, let them have the idea of that. So sampling techniques can be of two types. What are they? Probabilistic and non-probabilistic sampling techniques. Okay, when we say sampling, especially probabilistic sampling techniques, what does it mean? Okay, so there is every possibility that each and every element, for example, 19 students as of now, they have equal chances of getting selected into sample. So such techniques are called as probabilistic or okay, probable sampling techniques. Okay, so when there are no equal chances, that is completely opposite and it's called as non-probabilistic sampling techniques. Okay, so today we will be talking about different types of probabilistic sampling techniques. Okay, if you want to write down, please write down page number 133. Okay, after this class also you can refer them. Okay, you will get an idea about that. Yeah, last class 128. Okay, I don't know. Please check it out. Okay, so today's class it is about 133, page number 133. If you don't have textbooks also, no problem. And if you have textbooks also, it's better that you not to go through that because we would be telling you the gist. After that, afterwards you can check the material. Okay, so first one, systematic sampling. So systematic sampling. Second one, random sampling. Third one, stratified or random sampling. Area sampling, cluster sampling, then multi-stage sampling. So I need not tell again what they mean by probabilistic sampling techniques. So all these methods are equal chances of getting selected. If I have 19, if I have 50, 100, 200, 300, 500 or 1000 population, and if I'm drawing sample, if I say it is a probabilistic sampling technique, then all the 1000 have equal chances of getting selected. So 1 by 1000's chance of getting selected. I repeat, it's not that we're talking about little number, where we're talking about 20, 30, 40, hundreds to thousands also. If all the defined or the limited number that is 1000 or 1500, if every element or every individual have equal chances of getting selected to my sample, that sample can be 300, 400, 500 out of 1000. All the 1000 have equal chances. So that is called as a probabilistic sampling technique. And mostly It's recommended that you use this probabilistic sampling techniques. Okay. The first one is systematic sampling technique. So as the name suggests, there is a system followed. The system is that of a number is followed to select the required number of the sample. If I have 100 students and if I have to draw 25 sample, okay. So according to this particular technique, which is called a systematic sample, 100 divided by 25. Please use chat box. What would be the answer? 25. 100 divided by 25. Out of 100, I should have or draw 25 sample. So 100 divided by 25 would be, yeah, please make use of chat box. Excellent. Yamuna is saying 4. So with this particular method, if I have a list of 100 students randomly selected, that list doesn't follow any order. And based on the number, what I'm getting as 4, if I start picking every fourth number, then completely when I reach up to 100, so I will be getting 25 samples. So what all would be every fourth number? Please, can anyone write down? 4, 8, 12. Yes, 4, 8, 12. Likewise, if I go to up to 100, so I would be getting the required, yes, 25 samples. Or simple, if maybe 20 or if we have 19 students as of now, so if 20 students, I should draw 5 samples. So 20 divided by 5 would be again 4. Okay. So okay, Jagri is saying something. Okay, let me check that. What is that? But how will come back and remove the rest and restart? Come back, I did not get you. So if I have 100 students and if I have to randomly select, giving equal chances to all the students from 1 to 100, and if I have to draw okay, 25 samples. So with this particular system called systematic sampling, so every fourth number I will be selecting. So from 1 to 100, everyone is okay selected. Okay. And the other thing is that I don't know who is on 4th number, 8th number, 12th number, etc. As a researcher, I don't know who is on that particular number in the list. So this is how there is no chance or bias in selection. Okay, for example, 20 divided by 5. Okay, 5 4s are 20, so 4th number, 4, 8, okay, 12, 16, like that. If I keep selecting, so I would be getting 5 sample out of 20 that is covering from 1 to 20. So likewise, you can make use of this particular system if this particular system population is known to. So beforehand, so this is the condition that you should know what is the total number of population you have and how much population has to be drawn. So if you know that, based on that, if you try to divide them, so you will get a number that is called as nth number. So based on that nth number, if you keeping on picking the sample from first to the last, so you will be getting the required number of sample, not only from the starting, not only from end, but you get across throughout the total sample, okay, or the population number. Simple. But the advantage is very quick. So all the numbers are covered. That means total 100 covered. Very quick, very easy method to draw them. The disadvantage is that only the particular number candidate is picked, rest of them are eliminated. So only unless and until if it is randomly or without any order, as I keep on telling, if these numbers are based on a order, for example, either increasing or decreasing order, in terms of their intelligence or achievement, etc. So this can again land up, or this can again land you in erroneous or wrong picking of people. So when they are without any order, without any logic, and if I make use of this particular number, so I'm going to get the required number covering the entire 100 people. The only disadvantage is that if by chance factor, the number which I'm fixing, and if I start picking that particular numbers only, and by chance factor, if those particular numbers by any chance, if they are fault or if they are very good, so this is how I'm going to get either completely good or completely bad, okay, representation of the complete sample. Okay, that is only a limitation, and only that particular number is fixed. Between numbers, for example, 4 and 8, they would be ignored. So that is the limitation of this particular systematic sampling technique. Okay, second one, random sample. Okay, random. What is mean by random? Okay, now you might have understood what is the importance of randomization in research. Very, very, very important. So when we talked about the experimental designs also, we discussed that when randomized through experiment, when you don't completely randomize, they become semi. When complete randomization is missing, they become non-experimental designs. So when it comes to sampling technique also, so when you're trying to draw randomly, okay, so they are going to be very, very significant in terms of representation of the population. Okay, so random sampling technique. So drawing randomly without any order, without any bias, or without any chance factor. Okay, simple randomization or simple random method. Okay, simple randomization, as I said, a simple lottery method. So this is also called as fish bowl draw method. Please write down. So under random sampling technique, so we have three. Fish bowl draw method. Fish bowl. A bowl would be there. So as we do it in lottery method. Okay, so all the 100 numbers or 100 students or population would be dropped into that. And from that 100, so I would be randomly picking if I need 25 students. So it is a simple lottery method, which is also called as fish bowl draw method. So if you get this particular word in exams, okay, don't get confused and don't worry. Simple lottery method is also called as fish bowl. You should remember that in a bowl you're drawing or you keeping all these particular numbers, okay, or chits of all these particular 100 students, and from that you randomly picking the number you want to have as sample. Maybe 100, out of 100, maybe 20, 25, 30, based on the requirement. So how many if you would like to draw? So if you're drawing them randomly, so that will become fishbowl draw method. Okay, that is the first one. And second one, using table of random numbers. So as we have tables, table books we have. So in the same way, okay, random numbers, it's also called tippet numbers. Okay, tippet, east, and the fishers. So these are the people. Okay, fisher is a person who for the statistics. Okay, so this particular people, they have worked exclusively on this particular randomization technique, and they have come up with 10,400 numbers, combination of 4 digits. I repeat, 10,400 numbers, combination of 4 digits. Okay, they have done a very extensive research on that, and they have said certain numbers. Okay, so based on using the table, so numbers would already be printed in that particular tables. So if you pick that particular numbers, your job is done. For example, if you want to write down page, write down in page number 136, they have given a table. For example, 29523170. So I have list of 10,000 now. I can directly pick a person who is having this particular number 295266413992 because they worked on this particular randomization procedure and they have come up with numbers which represent randomization maximum. So there is every possibility that when you use these particular numbers, which are printed in a form of a table called tippet random numbers. So based on that particular numbers, also you can pick. You have 2000 sample from that if you want to pick okay, the required number. So based on the numbers which are given in this particular table, so from 1 to 2000, if you start picking, so you will get the particular required number of samples. So making use of pipette numbers table, random numbers table. So numbers are printed and they would be available as a tables form. So if you have this particular tables list, what number they have given, if you start picking that particular numbers, no, your sampling procedure is done. So that is another way of okay, randomization or simple randomization. The third one, method of computer determined randomness. Okay, computer determined or computer generated numbers. Simple. So manually you can pick using fishbowl method or using tables also you need to pick manually. But if you assign this particular job to a computer, so it will randomly pick certain numbers. What is the best example? Randomly pick numbers. For example, if you get ATM pins now, ATM pin numbers for the very first time, when you collect from this particular banks, so they are randomly generated computer numbers. So like that, if you assign the total list to these particular computers, so they will randomly generate certain numbers. Say out of 100, I need 25 samples. So 25 numbers randomly it will pick and it will give you. And simply you just pick those the participants, members from the 100. So your purpose is fulfilled. So second method is randomization, which is as simple as that of a simple lottery method, which is called as fish bowl method. Okay, so even when you get in exams, no, please do remember that fish bowl draw method is nothing but simple lottery method. That bowl they call it as fish bowl. So in that you're dropping all the numbers or chits. As we know, we are very familiar with this particular process. The only thing is that technically they're calling it as fish bowl draw method. Please do remember that. Second one, with the help of tables already entered, tables are available to us. They're called tippet random numbers. You can have these numbers and directly you can start without thinking, without you coming up with random numbers. So already numbers are given, you try to pick those numbers. Third one, you assign this particular work to computers. So computers will generate certain random numbers out of the total and what is the required number you want. So if you start picking those particular numbers, your purpose would be fulfilled. So this is with regard to simple randomization. Okay, that is called as a random sampling method. Then stratified random sampling. Okay, what do you mean by stratification? Stratification, please make use of chat box. Stratification, segregation, separation, categorization. So all these are the names of this particular method. So where if you have heterogeneous group of population, where they can be divided into certain strata or a category. If you start dividing them, okay, so that is called as stratified random sampling technique. Best example can be, if I have this particular 20 students, okay, I'm adding one more and saying 20 students, okay, on what basis they can be divided into two groups? Just think about looking at the names. Excellent, excellent. Okay, male and female. So readily available, they are heterogeneous. Two separated groups. You agree with me? So each particular category is called as a strata, a subgroup. Male, female is good. Excellent. If I have to further, okay, go for an extension. Okay. So males from maybe a arts background, right? Mathematical background, likewise also I can still further divide them. Yes, graduation level. Okay, because this is a PG program, no? So everyone would be having graduation. So that is the reason I said based on maybe a broader classification like arts and any other social sciences. You getting me? Based on socioeconomic conditions, for example. So how many socioeconomic conditions can we divide? Please make use of chat box. Socioeconomic conditions, 3, good, excellent. Jagdish saying good. Urban locality, okay, urban, rural, urban, semi-urban locality, location we're talking about. I said socio-economic conditions based on economic conditions. Yes, yes. Middle class, below middle class, above middle class. Okay, yes, low income group, high income group. Okay, that is one segregation. Okay, good. But in general terms, what we use as middle class, below middle class, above middle class. Can that be done? Because they can be segregated. There are specific demarcations based on which I can separate them. So male, female, the most common one. To add another level for that, based on graduations, based on their education qualifications, based on their socioeconomic conditions. So if one particular sample, if it is heterogeneous, and if there is a scope that I can divide them into different strata and check how they are. Okay, for example, the scores, or what we call as the exam results. So how this is spread across the socioeconomic conditions. So how well members from different socioeconomic groups are performing in exams, maybe in a board exam. So can I have that? So how are middle class students doing, below middle class and above middle class? So what is their performance at one particular exam? So I can study that. So this is called as stratified random sampling techniques. Male, female, yes. Okay, so likewise. So based on location, as Jagdish was saying, urban, rural, semi-urban. A segregation, a strata, category, or a subcategory. So if that can be done, it's called as stratified random sampling technique. So here the limitation is that the population is not homogeneous, it is heterogeneous. The composition is of heterogeneous. So because of heterogeneity, I can be able them to divide into different strata. Okay, a clear-cut demarcation on which I can divide them into different stratas. Okay, the disadvantage is that as it is very easy to segregate, if you do any mistake in identifying the separate stratas, if you identify a wrong strata or a wrong category, or if you mix up different categories, so the results can be okay, not very genuine, or they would be with errors. Because if you cannot demarcatedly or specifically, if you cannot divide, okay, middle class and below middle class, and if you start mixing them, and if you say, okay, this is what the results of, okay, below middle class people, so this is how you land up in errors. So how is this sampling done? Sampling is done very simple. If I have this particular 20 students, I can divide them based on, okay, males and females. That's it. So these are randomly, okay, participating 20 students out of 850 students. I don't know about their backgrounds. The only thing is that they are my particular psychology second year students who are participating or attending this particular online class. So out of this, I don't know. By looking at the names, etc., I can start dividing them into males and females. And if I check how good they are in understanding or getting this particular concept, so this is how I get this particular stratified random sampling technique. Okay, so stratified random sampling techniques. So in this also there are two, proportionate and disproportionate. Okay, when we talk about proportionate, okay, it is the equal numbers. So males would be equal, females would be equal. Okay, males are equal and females are equal. But you can't infer to all 80-50. Yes, that we talk in the last part. Okay, don't worry. That we talk in terms of sample size. Okay, don't worry. Sample size, we will talk about that. Okay, yes, I know. I take everything into consideration. So I thought of telling this at the end, because end we have this particular topic called sample size. Okay, so proportionate and disproportionate. Proportionate is where you have equal numbers. Okay, under both categories. Where it is not possible to have equal numbers, okay, then you try to give more weightage, okay, to one particular group. For example, if you think male and female, okay, opinion has to be taken with regard to this particular online classes. By chance factor, out of these 20, if most of them are males, but I would like to have the equal number. You getting me? So if I start picking, okay, 5 male and 5 female, actually in the population, they are not equal. In the population, they are not equal. Male and female are not equal. But I am trying to give equal representation when it comes to sample. So that is called as disproportionate. The actual number in the population and the actual number what I'm taking as a sample, so that is different. That is disproportionate. If based on the number or percentage of they are present in the population, according to that only if I'm taking the number, so that is called as proportionate. So if I think one particular group is underrepresented, and if I'm trying to give more number of sample, that is equal number. As I said, male and female, though they are not equal, maybe by chance factor more of males are present in this class, but I try to pick 5 males and 5 females. Okay, maybe male's number is correct according to their present, but maybe female, they are not that much of percentage of 5. So this is how proportionate and disproportionate stratified random sampling is done. Okay, but the simple thing you remember about categorization. Best example, male and female, socioeconomic conditions. So that is called as stratified random sampling technique. Okay, then cluster sampling. Please write down cluster sampling. Cluster sampling. So what can be a cluster? Cluster. Yes, groups, or we talked in stratified about categories, strata. So if it can be further divided into subcategories or substrata based on commonalities, if they can be grouped together and studied, okay, so that is called as cluster sampling. Okay, so primary, secondary, tertiary, etc. Okay, if they can be further divided, okay, yes, males and females done. But for example, you said about locality. So within rural, okay, mandals, etc. If we further start dividing them, so if a geographic area is very less, okay, so that is different. But when it is very large, and if I have to study that particular, okay, large number, but they have certain overlapping commonalities, then that larger can be divided into subcategories. And if I randomly pick that particular subcategories and if I try to study them, okay, so that is called as cluster sample. Okay, so then next, area sampling. Area. So this is very common based on geographical areas. Based on geographical areas. If India has to be divided based on geographical areas, so what is the common division we make? Yes, states. We have states. We belong to, yes, religions also, okay. So when we say area, so it particularly talking about geographical areas. Okay, cluster can be with regard to religion, etc. But area sampling, yes, excellent. Swarup said north and south. So total India, maybe if you have 30, 31 states, another 6 or 7, okay, union territories, etc. So studying all this may not be possible. So for that, what is the common division we make? We say North India, South India, East and West parts. You agree with this? Based on the geographical areas. Okay, so complete India, you have to survey. So how much of time in terms of years it will take? Getting me? For example, sample, okay, population surveys, yes, they have to be done because they should have the complete total number. But when it comes to certain opinions, etc., so can they take, or is there is a need to have each and every person asked about so how they are feeling about this particular scheme or what is their opinion about this particular, okay, issue? Maybe no. So for that, they can start dividing based on certain geographical areas, because one particular geographical area is expected to have the common, okay, the temperatures or the climate changes. Okay, so based on that particular notion, geographical areas are divided, like we had North India, South India. From South India also, we can randomly pick certain states. Okay, within that certain, okay, mandals, etc. And if you start randomly doing survey, so this is how area sampling is done. Okay, so area sampling tech. A large number of population, if they have certain common sharing or overlapping, okay, with regard to climatic changes, etc. Based on the geographical areas or locations, if they can be clubbed together and if they can be used for our, okay, sample selection, so they are called as area sampling techniques. Okay, the simple as we had discussed, okay, north south India kind of a thing. So within south also randomly certain states can be picked. Okay, like we have our mental health survey which was done in 2000, okay, 10 or 11, etc. Okay, so where they randomly pick certain states. Okay, so did you had that? Maybe no. Have you done with that particular surveys or etc. practicals? This is the first practical maybe, right? Yeah, maybe in the coming practicals you have this particular thing about surveys and all that. Okay, sample has to be taken physical only as technology improved. Can it be done sooner like a, yes, this already we talked long back, because if I start sending you a link, there is no guarantee that only Jagadish would be filling that. You agree with this, Jagadish? If my particular Jagdish feels that, okay, I can take it seriously about his opinion on online classes, but maybe some of his family members, maybe if his son or a daughter, if they are using this particular mobile phone, if they got this particular link, or maybe Jagdish is busy and if I've given this particular opened link to his children and ask them to just pick yes or no. So can that be taken as seriously? May or may not be he would have done it by himself. There is a chance factor, always a question mark. That is the reason we talk about empirical data. You always go make a direct observation. You collect the data. You try to analyze that particular data to arrive at a meaningful conclusions. This is the reason research is going to take years to get. It's not as simple as that. You just send using technology and you got something where it can be readily generalized, because at every time if there is a question mark, no, the entire effort is gone waste. Because I cannot rule out, no. Though the person would have done genuinely, but there is every possibility that the other way also it can be done. So that is the reason research is completely different. And this is how it is time taking, more finances is required. Because you need to go, be there in your presence, that has to be filled, collected, and you should try to analyze that. Okay, this is how it goes. Okay, so how technologically you are improved? Is there a government organization? Yes, it's there. Any government organization, no? They are interested. For example, NGOs also. Certain NGOs, they ask, okay, some scholars or maybe interested people to conduct survey on behalf of themselves. They fund for that. So NGOs, in terms of a project, they take people, if they make them do surveys, so that they want to do certain improvements based on the survey results. NGOs can be there, government organizations. So government organizations, for example, like ICSSR, etc. Okay, they do fund, they do ask interested people to apply for these projects and to do this particular service. Yes, even our so-called private organizations like Ford or etc. Okay, they also have these NGOs. they have this charitable trust, etc. They do fund, they do would like to know what is the health status, etc., awareness, etc. And based on that, they give some moment also, funds also. So research can only be done, not only done by academics, but by individuals also, okay, based on the particular interest of government, non-government, private organizations. They are willing to fund, yes, it can be done. Okay, population census is research. It's not complete research, but the main intention of that is to have a total count. So when you talk in terms of research, we are trying to look at cause and effect relationship. So this we already discussed a bit earlier. So research, we are trying to find out what is cause and what is effect. You agree with that? Census is a type of survey where you are trying to, okay, note down the complete number of the population. Okay, so area and cluster and area sampling. So area sampling is especially used when large geographical areas like in India. For example, if they have to do a survey on, like, for example, as I said, mental health survey was done to know, so what is the prevalence of different psychological disorders. So maybe not possible to do survey of all 100 or 100 plus crores of population. So that is the reason, based on geographical areas, because they know geographical areas share certain common climatic changes or temperatures. So based on that, our health can have influence. So that is the reason they have picked randomly from different 4 geographical areas. Okay, randomly they pick certain states, mandals, etc., and they start doing that. Okay, then multi-stage sampling. Multi-stage sampling. So this is a type or a modified cluster sampling. Okay, so which is done at different levels. Okay, as we talked about at different stages, multi-levels. Multi-levels. The country, then states. So within states, the cities. So within cities, okay, if they are interested to know about the awareness of psychological disorders, so certain cities they select, they try to make a awareness survey, or if it's to do with certain factories or organizations, so within that particular selected or randomly selected states, so they randomly pick certain organizations or industries. They go, they talk to that particular employees and take their opinions. So multi-stage or multi-stages or multi-levels. Okay, so this is about multi-stage or multi-level sampling. So state as a unit they take, then they again divide them into, okay, country as a unit, then state, within states, okay, different mandals, and within different mandals, different particular, for example, organizations or educational institutions, for example, then they pick different educational institutions. From that, if they would like to know, especially girl child or girl students' opinion on, maybe, for example, increase of marriage age to 21. You getting me? You can directly go and talk to all the women who are maybe 18 and above, but they're not doing that. At different levels, they are doing that. So they're picking, for example, as a country as one unit, then they start dividing that into different states, randomly picked states, within that randomly picked, okay, district headquarters, mandals, etc. And within that, different organizations or different management schools we have. So from that, different types of managements, they randomly pick certain schools under each management, and they start getting information, or they try to know information about, maybe, as I said, about increasing of age of marriage 21. So this is how they can get interpretations at different or multi-levels or combination of levels. So this is called as multi-stage sampling techniques. Okay, so all these sampling techniques are under probability sampling techniques. You should only remember that when we say probability, there is every possibility that each and every member of the population have equal chances of getting selected into sample. Simple. And I'm saying no, as someone said about sizes, no. So when there is equal number or less number, and you're looking to have a sample, if it is okay, the number is same or more or less, where you can go with that particular size numbers, no, then you need not go with sampling techniques like that. So if I have 200 population, if I need a sample of around 200, so whoever is available, I can directly take. You getting me? Only when if it is 1,000 or more than 1,000, I have to make a reasonable number. Then only these sampling techniques, etc., will come into picture. If not, there is no need for the sampling, etc. Okay. So actually, this is the sampling size, etc., is the last part. Okay, we will talk about that later. Then non-probability sampling techniques. So which is completely opposite to that of probability sampling technique, because not all the members have equal chances of getting selected into sample. Like for example, if you have this particular lottery method or fishbowl method, if I have 100 chits in a ball, so all the 100 individuals have equal chances of getting selected for a lucky draw. So if that is not guaranteed, then it will automatically become non-probability sampling technique. Okay, these are also called as deliberate sampling, purposive sampling, and judgmental sampling. Deliberate because it is depending on the deliberation or a decision of this particular researcher. This particular researcher. Okay, deliberation or based on the particular choice or judgment or based on the purpose of the researcher. So if he is giving certain weightage or certain importance to one, ignoring the other one, it is called as non-probability sampling technique. Because when we have certain reservations or certain priorities, ignoring certain other things, that itself is a bias or a chance. You agree with that? There is no equal guarantee for all the people, whoever is having or who can be included into population. So they have this equal chances of getting selected. Okay. So now we will look at different types of non-probability sampling techniques. Okay, the first one is convenience sample. Okay, convenience sample. So as the name indicates, it is whose convenience? Please make use of chat box. Whose convenience it is? Yes, researchers. So researchers' convenience. Okay, the best example, this I keep telling. For example, a slum area, and if my particular student is from the Ambedkar University, so he thought of going to a slum, but when he came out of this particular Ambedkar University, so besides very big buildings, you have seen poor houses. Yes, it can be a slum or a low economic group. And if you thought of, okay, why should I go to a slum which is very nearer, okay, which is very far? I need to look at, okay, where those places are I should visit. Then why won't I just collect the opinion of these people? Because it is very adjacent, nearby to the campus. And if you start speaking these particular people's opinion and they start telling that this is what the opinion of slums of Hyderabad. Is that correct or reasonable? Okay, comparing to the big buildings, what he is saying is that they are also poor people. No? So it is whose convenience here? It is whose convenience? Researcher's convenience. Researcher, rather than going to a very long place, so is thinking of, why won't I pick the very adjacent? So maybe if they call it as Islam, the incomes or how much finances they are getting per month would be different when we're talking in terms of another slum which is located at a outskirts or somewhere in Hyderabad and which is in Jubilee Hills. You agree with this? Okay, the income what they're getting will be different. Though they look to be very small houses or poor houses compared to bigger buildings. But this doesn't mean that they represent the true slum population. And because of his convenience, thinking that it is very nearby, and if we start including them as into sample, so this is how it can be convenience of the particular research. So that is the reason it is called as convenience sampling, known as also incidental sampling. Is that clear? Convenience sampling. So there can be more ideal slums, but as it is very nearby to the particular organization, so if he starts picking them because of his convenience, so this is how there is no equal chances of these particular slums. So we have not taken a list of all the slums, and out of that, which particular slum we should take randomly. We have not done anything, but it is as it is nearby to him. So just because of the distance factor and all that convenience, we have decided to collect data there. So this is how it becomes a convenience sample. You getting me? So you have not taken, yes, time and distance. The time at which it's done. Time also matters, yes. So based on his convenience. Okay, so I talked in terms of a distance. So maybe yes, it can be in terms of the time. According to his convenience is going, and whoever is available in that particular time period, so he's trying to talk to them. Okay, convenience sampling. The next quota sampling, quota. So what is this quota? Quota sampling. Okay, you give certain quota of representation of population in sample selection. Okay, so when you have different heterogeneous populations, based on their representation, if you start giving a certain number in population, and from that if you're drawing one specific number or a quota to be included into a sample, so this is called as quota sampling. The only thing is that it is not done randomly. So they are not done randomly. So again, whoever is available at that one particular time period, or when the particular researcher is visiting that particular targeted groups, so he's trying to include all of them. So this is called as, okay, quota sampling techniques. Okay, they try to give a designated number in terms of representation in sample selection. Okay, for example, if you have different socioeconomic groups, etc. Okay, so they are trying to give certain quota to them. The only thing is that the selection is not done randomly. So there is no guarantee that all would be included. So he's not bothered about knowing the total number available in that one particular group, and from that, how to select them randomly. But whoever is available, so non-randomly, is trying to include them. The only thing is that if they belong to that group, it's enough. So it's not bothered about so how many total number are there. From that, how to draw a systematic or a random sample. So randomization is missing. So this is called as quota sample, especially like socioeconomic condition, all that. So this is done. You should always remember that they are again drawn as per the wish of the researcher. So no particular randomization, as we talked in terms of probability, is missing here. Okay. The next important one is a snowball technique. Snowball technique. So quota, as we know, so giving a representative number as per the requirement or as per the will or as per the wish of the researcher, and no randomization. So that can be common sense issue. We can try to know that. But snowball technique. So most of them they get confused with the snowball technique. So snowball technique is a sociometric or socialization process. Okay. So what is the sociometry? Have you got an idea about the sociometry? Sociometry or social acquaintance in simple terms. So this particular technique, just say that, okay, it start at one point of, at one particular level. From there, so those people, they try to spread it to their acquaintance. And from there, they start spreading it to their acquaintance. So this particular technique is used to spread information. So this is used to know so how informations would be spread and in what directions and how is it spread. For example, we know about this particular dialogue, no? You tell to three people, that three people will again tell to other three people. Okay, maybe Stalin, hoga, Stalin movie dialogue. Did you remember that? So sociometry, social acquaintance. Okay, you have group of people, so you introduce them, you tell to them, and then you ask them to spread it to their acquaintance. So again, from there, the people whom they know, they start spreading to that. So this is how, as a ball, it will be rolling from one point to the next levels. Snowball. So initially, when snowball would be there, no, it would be small in size, but as it keeps rolling, will the size increase or decrease? Make use of chat. So when a ball is rolling, yes, good. Jagdish saying increases. So as it is keep rolling down, so it would be, okay, taking, or the snow would be, yeah, Vilma is also saying it increases. So as the ball keeps rolling from up to down, so more and more snow would be touching or attached to it, and this is how the size is going on increasing. So this particular way, this particular technique is used. That is the reason they are calling it as snowball technique. as a small ice ball rolls down and increases in size because more and more snow is getting attached to it. In the same way, so this is basically a sociometry principle technique. So how information is spread across professionals, or how awareness programs can be spread in people, the ways and etc. if they would like to study. So this particular technique called snowball technique is used. Okay, they call this particular, okay, people representatives, they try to tell to them, so they spread it to the next level, again they spread it to the another level. So this is how dissemination of information, okay, is done. And if those particular patterns are studied, so this is called as snowball technique. Is that clear? Snowball technique. Okay, just you think or remember of a snowball when it rolls down, so it decreases or increases. Obviously, it will increase because more and more snow would be getting, okay, attached to it. In the same way, you tell to some people, they tell to the next level, or their known people. Those people they again tell their known people, and this is how, like a snowball, increases. So this is how the information is spread from one point to the different people. Okay, snowball technique. Okay, please do remember this, because sometimes in short answers, no, they ask this particular sampling techniques directly. They may ask you what is simple randomization, or what is cluster sampling. For 5 marks, they will ask you. When it comes to a essay, no, they may ask you what are the different types of probability sampling techniques, like that. So what is sampling? What are the different types of sampling techniques? So these particular sampling techniques are as very easy as well as they would be coming for exams also. Okay, so please do pay attention for that. Then referral sampling. Last one we have is the referral sample. So what is a referral? Referral is giving a reference. Reference. So you give reference to some of your friends, no? Known person, yes, introduction. Good, good, good. Excellent. Okay, you give a reference and you ask the person to go, no? Go and please go to that organization, okay? Tell my name, etc. So in the same way, so this particular referral sampling is done when the target group or the population, which is very sensitive, which are very sensitive, like ethnic groups, disadvantaged groups, where members other than their community have little access to know about it. I repeat, ethnic groups and disadvantaged groups, where other than their community people have very little chances of getting into them, to study them, to interact with them. So this particular referral sampling is used. So as a reference, you make use of a known person, one among the community member. So with the help of that particular member, you try to get access to that particular community with the help or with the introduction of that particular person. So you become part of the community now. You try to study that. You study to make, you try to look at making observations, collect data, and you come up so that you try to interpret and find meaningful conclusions. Did it make it any sense? So you take reference of a known person from that community. So with the help of that particular known person, you try to get access to that particular sensitive groups, like ethnic groups, disadvantaged groups, because the other community or out of their community members have very, very little access to get into that. Either they don't allow you, If they don't allow you also, may not be you getting the required information what you would like to know. Unless and until if a known person or well-known person among one of the community members, if they give you certain help, they provide you certain help. With the help of them, if you try to go into that particular community and try to make an observation, so then only it is possible. So such type of sampling is called as referral sampling. So you take a reference of the community member. That community member should be making a little bit of acquaintance, a known person or influential person. So without that, the other members will not allow you to get into the company. Because of that particular referral person, they are allowing you to get into the community. So this is called as referral sampling. Was it clear? Referral sampling? Certain tribes, ethnic groups, disadvantaged groups, very, very sensitive groups. And maybe the other question can be like, why they don't allow you? Why they don't allow people from other community? Security is good, excellent. Because they are sensitive, good. And especially if you are from another community, so if you are trying to observe them, make some observations, collect some data, and what you are going to do with this data? You agree with this? So how this data is going to be used, or how this data is going to be misused? So they have these reservations with them. You agree with that? So unless and until a known person, one among them says that, okay, this is what the purpose and this is what they're trying to look at, then they feel a bit comfort, then they allow you to get into the community and make you some observations. So this is called as referral sampling. So why is it not a probability sampling? Because the person who is making a referral and who can listen to him, then only, or those people only come to you, try to talk to you, give some information. So this is how, again, there is no complete access to all the members of the community, but with that particular referral person, so whoever is having a good relationship or whoever listens to him, so those people only you can have access. So that is how not everyone is guaranteed. This is how it becomes a non-probability sampling technique. The help of the person we going, so the person, whoever he introduces or whoever agree with him, so they come, they talk to you, they try to give you some information. So not complete, not all the members are coming and willing and giving you the information. So this is how it becomes a non-probability sampling technique. Okay. So with this, we have done with probability and non-probability sampling techniques. As I said, a direct essay question can be what are different types of non-probabilistic sampling techniques. So generally there will be a question like this. So what is sampling or what are different sampling techniques? Okay, from either probabilistic or non-probabilistic sampling they ask. Or in short note, directly they will ask you. Snowball technique, cluster sampling, like that. So it's very easy to score if you know this particular techniques. They are very simple. Okay, and I wish and I give a suggestion that you be prepared with this easy topics rather than you pick some statistical topics. It's always better that you pick either hypothesis, types of hypothesis, variables, types of variables, sampling, and different sampling techniques. Okay, these are important. Then we are left with small unit under this block. Okay, sample size and sampling error. Okay, sampling error is when the total characteristics or the measures, especially yesterday we talked about, the true representation is of the population, if it is missing, then it is called as a sampling error. Okay. For example, Jagdish asked me, if 850 people we are talking and just we have 20 people, so how good they represent? Obviously, the representation would be very, very, very less. So that distortion or that difference in the true representation of the actual population is called as sampling error. So when the representation is the complete reflection of population in terms of sampling is missing, so that missing or that distortion or that change in the representation is called as sampling error. Okay. And also we know that when the number in terms of sample is less, will that be going to give you good representation? Please make use of chat box. Maybe. No. Good. So what we should do? So to have more and more representation is what we should do. Okay, Vilma is also saying no, good. So to increase representativeness, what we should do? Select a proper sample size. Okay. So what is the proper sample size? Okay, we'll talk about that too. In other words, what it can be called as? Increasing the number of samples. You agree with that? Increasing the number of sample. You agree with that? Okay, more sample. Yes, good. Vilma is saying yes, good. So, more the number of sample, less the sampling errors. Because as the number of samples is increasing, the representativeness or the reflection or the generalization of the findings is more and more. So, more the number of sample, less the number of sampling error. So, sample size and sampling error are inversely proportional. Less sample size, more sampling error chances. So that is the reason you should take a representative number or a good number of sample. So if you're talking about 100 and if you have only 20 or 10 people, and if you're saying, so this is what my complete 100 students are thinking like this, maybe not. The actual would be different and what we are getting is different. So that difference is called as sampling error. Okay, what is the minimum? There is no minimum, there is no maximum. There is no minimum, there is no maximum. Because sample size has to be increased. So how much sample you take? Okay, so there is no hard and fast rule that 1/10 of sample has to be taken like that. So they say good number. That good number is again dependent on, even if the sample size is more, it is not necessary that it represents all the cases right. No. When you draw sample using probability sampling techniques, when it is a good number of sample, it has to represent your population. If you don't draw scientifically, if you're giving any chance factor, then the results would be distorted or there would be difference in what the actual is and what you're finding. So try to draw sample scientifically, that is using probability sampling techniques. There is every possibility that the representation would be poor. So representativeness would be more, which says that sampling error is less. Okay, should remember that there is no okay, line which says that, okay, this much of percent has to be taken. But, okay, technically, if they talk, no, they say below 30 and above 30. Below 30, they call it as a small number. Above 30 is a large number. So, above 30, bole to, what is the last limitation? Bole to? No limitation. Okay. So, based on the factors, as I said, how much time we have, how much of resources we have, so how much we can take as a sample, it depends upon the researcher. For example, if population is around 300 and generally for a PhD level, okay, they have this particular number as a minimum of 300, 400 samples. So do I need to do again a sampling technique to draw, or can I include the complete total number of 300 or 400? So what can I do? I can take complete that 300 or 400 because that is a minimum number. You agree with that? Only if it is maybe double of that, for example, 800, the total population, you have to draw a 300 or a 400, then I should make use of sampling techniques. Okay. So when sample has to be drawn in hundreds, for example, 300, and total population is also around 300, I need not use a sampling technique to draw. I can directly take away that particular 300 as my sample because it is at a PhD level. So based on the purpose, based on the other factors like how much time you have, how much resources you have. So based on that, you decide a number which is good enough to give a representation of the particular total group, which is called as population. Technically, in terms of statistics, below 30 and above 30, they talk. So below 30 is a small group, above 30 is a good or a smaller and larger group. And you should always remember that more the number of sample, the inferences which are drawn from the sample would be having good representativeness of the population. It doesn't mean that you're keeping on increasing the sample, thinking that it will be more and more representative and the sampling error would be less. Okay. So there is no fixed number of drawing a sample. So it all depends upon the how or what number a researcher feels good enough. Okay, so if it is around 800 now, I can easily draw, okay, a 200 to 50 sample. Okay, so nowhere it is written. So what percent has to be drawn? Some say 4%, 5%, like that. So you should only remember this logic that less the number of sample, the sampling error in terms of inferences drawn from sample may not be good enough to represent the total population. So that is the reason. So based on the factors, you try to take a good number of sample. Okay, it depends upon the variability or individual differences among the group. For example, if you have to do a intensive study, intensive study can be, for example, qualitative studies. Qualitative, for example, like non-experimental designs. What are non-experimental designs? Longitudinal study, for example. So is it possible to have a large number of samples there? Longitudinal. Longitudinal. Yesterday's, did you remember? Very time taking, in-depth study has to be done. So if I go with a large number, can I do that? Complete the experiment? Maybe no. So if I'm doing a quantitative study, where numbers can be assigned, numbers can be drawn. Yes, I can go with a large number. when I'm doing an in-depth study, like a longitudinal study, so it's always better that you go with less number. For example, if I have to do a categorization, stratified random sampling technique, if I have to use, so if I start with maybe a 200, and if I have to divide them into 3 groups, so under each group, how many sample would be there? You getting me? So that can be increased because I need to divide them into certain categories. So having a large number of population, so from that, if I draw a reasonable good number of sample, so that that particular sample can be divided into 3 groups. For example, 150, 150, 150 under 3 groups. So what would be the total? 450. You getting me? Because it has to be again divided into categories. So now I'm looking at each category, what is a reasonable number. So likewise, you have to divide them into categories, subcategories to take, or you have a large sample because they have to be again divided into different categories. For example, if it is a qualitative, like for example, longitudinal, continuous, has to be done for some years together. Okay, so you take a reasonable number, not in terms of hundreds, etc. Because 100 people, if you have to continuously watch, monitor, it becomes a problem. Okay, so this is how you should divide, or you should have a reasonable number, because more the number of sample, more representative it would be. So actual characteristics and what you're getting as a sample inferences, if they are not matching, that is called sampling error. So more the sample, okay, the inferences drawn would be more representative. So that would be matching with the complete population. So based on the type of study, okay, then okay, the classes or the categories you would like to divide them based on the availability of time, how much time you have, how much of resources you have, and also sort out about okay confidence levels, okay, 0.05 level, 0.01 level of significance. Okay, so based on the significance also, more the number of significance. For example, if it is 0.01 level, okay, the sample has to be increased 4 when compared to 0.05 level of significance. Okay, level of significance, it says that, okay, if it is a 5% significance, it says that 95% it is because of what the experimentation you are doing, and 5% of chances, the results can be having 5% of chance factor. Okay, when you talk about 0.1 level or 0.01 level of significance, it says 99% of the results what we're getting is because of your experimentation, and 1% is a chance factor. Okay, it's called level of significance. So more the level of significance, the more the number of sample you require. So these are certain okay, factors based on which you need to decide what should be the sample size. So nowhere it is written that you should have this much percentage. I'm again repeating. So this much of percentage of sample you should have. So nowhere it is written, because it is dependent on certain other factors. Okay. So with this we have completed our block 4. Okay. So hopefully we have another one class. So we will try to complete the block 5. If anything got missed in between, no, you try to read because the book is already given to you. Okay. See you all in the next class. Yes, you are well. Okay. Can we end this session? Chalo, see you all tomorrow or next class.